Good afternoon, class. Here's chapter 5, integrals, section 5.4, the substitution rule. We have done a big chunk of it, and we're going to continue finishing it off. Here's an example. We want to integrate the integral of square root of 3x plus 7 dx. So, 3x plus 7 is a choice of u. The derivative is 3. Therefore, du is 3 dx. Now, I'm going to show you two methods. In most texts, they solve for dx, but I've shown you an easier way. So I'm going to solve for dx, which means I'm going to divide both sides by 3, and dx becomes du divided by 3. And now this, we are going to write it as square root of u times dx is replaced with du over 3. Now this is simple enough, it doesn't make that much of a difference. So I can take the 1/3 out, and square root of u, of course, I'm going to write it as u to the power of 1/2. So it becomes ready for the power. So this is the way most texts do. However, the way I do that is this. I look at the du, and I notice number 3 is missing. So I'm going to put number 3, and I'm going to undo it by putting 1/3 outside. So when I do that, I get exactly the same thing. I believe this is a tad easier than having to solve for dx. Now, this is something we have seen before. 1/3 remains. This is 1 over 1/2 plus 1 u to the power of 1/2 plus 1 and a constant. That is simply following the power rule. 1/2 plus 1, 3/2. 1 over that is the reciprocal times 2/3, and the product is 2 over 9. Replace the u, and you get 2 over 9, parentheses 3x plus 7 to the power of 3/2 plus a constant. You can write it as a square root or not, so you could rewrite it in the following manner if you like. This is one way to write it. The other way, you can even write it in this format. I hope you remember this from algebra. 2 over 9, parentheses 3x plus 7, square root of 3x plus 7, and a constant. But if you didn't, it's not that big of a deal. This is fine. I want you to see both questions side by side because both of them involve ln x. When ln x is involved, that's the choice of u. Its derivative is 1 over x, therefore du is 1 over x dx. There are two ways to write it. 1 over x dx or dx over x, they are both the same. By the way, again, dx, as always, it belongs to the numerator. To make sure what we are dealing with here, I'm going to rewrite it in the following manner. The integral of ln x to the second power times 1 over x dx. Clearly, we have u squared times du. Again, we're going to use the power rule. So 1/3 u cubed plus a constant. Replace the u. 1/3 ln x to the third plus c. Please understand, this means ln x times itself 3 times. And since it happens all the time, I have to mention this. Ln x to the third means ln x times ln x times ln x. It's not the same as ln of x cubed. Those are two different things. Ln of x cubed can be simplified to 3 ln x. Don't mix them up. We're going to do part B, and to do so, we're going to rewrite it. So it becomes clear what we are dealing with. We are dealing with 1 over ln x times dx over x. Sometimes I write it in this format. Sometimes I write it in this format because I want you to see both mean the same thing. So now 1 over ln x, and you're going to replace the ln x with u, and itself 1 over u gives us a natural log. So natural log of u, an absolute value, plus a constant. Now replace the u with ln x. The final answer is ln of absolute value of ln x plus a constant. As always, you can differentiate the result. You get the same thing without the dx. And again, the reason we have those two questions side by side, because we want to compare and contrast. In this page, we are dealing with sinusoidal functions. Again, we want to see them next to each other, because in this case, it is the argument of sine that has the exponent, in which case that is the choice of u. Its derivative is 2x, therefore a du is 2x dx. So we're going to move the x next to dx, so it becomes clear we have everything except number 2 is missing. Again, in many texts, they solve for dx. I'm not going to do that because it's just a number. I'm going to put 2, and it's reciprocal 1/2. By the way, inside or outside the integral sign makes no difference. Remember that a multiplier, a coefficient remains a coefficient. So now you're dealing with 1/2 the integral of sine u du. The derivative of sine is cosine, but the integral of sine is negative cosine. So we have negative 1/2 cosine u plus a constant. And u is replaced with x squared. The final answer is negative 1/2 cosine of x squared plus c. If you differentiate that, you get the same thing without the dx. If we have sine and cosine, the one which has the exponent is a choice of u without the exponent. Sine has the exponent, so sine is the choice of u. The derivative of sine is cosine x. So du is cosine x dx. So we are looking at the integral of u squared du. And we use the power rule on that. 1/3 u cubed plus a constant. And u is replaced with sine, 1/3 sine cubed of x plus a constant. So to make sure we understand, by the way, as always, you can differentiate, you get the same thing without the x. To make sure we understand, what about this case? You look at the fact that you have sine and cosine, both of them. The one that has the exponent is cosine. Therefore, that is your choice of u. U is cosine x. The derivative of cosine x is negative sine x. Therefore, du is negative sine x dx. You can easily finish it. I suggest you finish it at home. So compare and contrast. This is a very good page to see how we deal with it when the argument has an exponent, how we deal with it when sine and cosine are involved and one of them has an exponent. Substitution for definite integral. The integral of 1 to 2, 2x, x squared minus 1 cubed dx. There are two methods. Class, when we want to do this by substitution, you can always go back to the original variable or just find the new limits. First and foremost, I'm going to put the 2x next to dx so it becomes clear to everybody that the more complicated polynomial, in this case, x squared minus 1 is a choice of u, and du is 2x dx. So we are returning to the original variable with u being g of x or x squared minus 1, and du is 2x dx. Therefore, we are looking at u cubed with the du, and we're not going to write any limits because the original limits 1 and 2 pertain to the original variable x, but not to u. So we're going to keep it this way for now. You know the answer is 1/4 u to the power of 4. That's a simple case of a power rule. And now, if I replace the u with x squared minus 1, I can go back to the original limits of 1 to 2. So return to the original variable, therefore use the original limits. This is pretty simple. If I put 2 here, I get 4 minus 1, which is 3 to the power of 4, which is 81. If I put 1 here, I hope you recognize this as 1 minus 1 or 0. So 1 makes it 0. 2 makes this one 4 minus 1, 3 to the power of 4. 81 over 4, you're done. As I said, the second method is to keep track of the change of variables in the limits of integration, which means first, the lower limit is 1 or a, and the function u is x squared minus 1. So if I put it in there, 1 minus 1 results in 0. So a equals 1 results in 0 for the new function. Therefore, that's the new lower limit. For the upper limit b equals 2, if I plug in 2 into this u function, 2 squared, 4 minus 1. So x squared minus 1 becomes 3. So the new upper limit that pertains to u is 3. So we can write this integral, the integral of 1 to 2, 2x, x squared minus 1 quantity cubed dx, is the same as this integral, but now we have the lower limit 0, upper limit 3. And we've already found this to be 1/4 u to the power of 4. And again, we can use those limits. If you plug in 3, you get 81. If you plug in 0, you get 0. 1/4 of 81 is 81 over 4, which gives rise to the following theorem. If g prime of x is a continuous function on the closed interval of a to b, and f is continuous on the range of u equals g of x, then the integral of a to b f of g of x, g prime of x dx is the integral of f of u du from g of a to g of b, which means just keep the track and come up with the new limits. That's all the meaning of this theorem. You don't have to memorize that. Understand? All you have to plug in a equals 1 into this for the new lower limit b equals 2 to find the new upper limit. That's all it means. So as an example, we have the integral of 3 to 4 x squared of 25 minus x squared dx. This is a more complicated polynomial. That is the choice of u. If we take the derivative, we get minus 2x. Therefore, du is minus 2x dx. We're going to put x next to dx, everybody. And now we compare, we see that this is square root of u. That's not a problem. But this is not du. And remember, in many texts, they solve for dx. I'm not going to do that because a number is missing. This is an easier way. I'm going to plug in -2. And I'm going to undo it with its reciprocal -1/2. It's important to pay attention to the fact their product must be 1 because you're not changing the nature of this integral. So with that being the case, we have negative 1/2 the integral of square root of u du. I'm not going to write the limits again. We will go over that in a moment. And this was done previously. I hope you remember it. We're going to change it to u to the power of 1/2. And we're going to say this, if I want to integrate, I use the power rule on that. 1 over 1/2 plus 1 u to the power of 1/2 plus 1. Don't forget there's a negative 1/2 in front. That's not going to go away. And so 1/2 and 1, they add up to 3/2. And this is now 2/3. And the product of these two numbers is negative 1/3. Again, we don't have the limits yet. So we can go back to the original function and we say we are interested in evaluating this expression minus 1/3 times u is going to be 25 minus x squared to the power of 3/2 from 3 to 4. Original limits, we can do that. Or we're going to put the 3 into this, which makes it 9. 25 minus 9, the lower limit is 16. We're going to put 4 into this, which makes it 16. 25 minus 16 is 9. And now we have the new limits. So if you use this one, the lower limit is 16. The upper limit is 9. We are going to evaluate this. To evaluate this, I'm going to put the negative 1/3 outside, everybody. It makes it easier. You can go this route if you want with 4 and 3. And then so we have 9 to the power of 3/2 minus 16 to the power of 3/2. And 9 to the power of 3/2 means the square root of 9 cubed, which is 3 cubed, which is 27. 16 to the power of 3/2 means square root of 16 cubed, 4 cubed, 64. So 27 minus 64 is minus 37. The product of these two numbers is positive 37/3. Again, you can go with the original variable and original limits to do the evaluation, or the new variable and new limits. Normally, the new limits are a tad easier. It's your choice. All right. Let's take the integral of x squared, parentheses 2x cubed minus 8 quantity cubed dx from 0 to 2. We have a bunch of polynomials. The more complicated one, 2x cubed minus 8, is a choice of you. Its derivative, du dx, is 6x squared. So du is 6x squared dx. To make sure we understand what's given, I'm going to put the x squared next to dx, and we notice we are in good shape. We have u cubed, except this one doesn't have number 6. And since it's a number, I'm not going to solve for dx. The easy way out, just to throw in 6, undo it with 1 over 6. It's reciprocal. So now you're looking at 1/6 the integral of u cubed du. I'm not going to write the limits yet because I can't write the original limits 0 and 2. So what are the new limits? You plug in 0 here. I hope you see, if you plug in 0, class, if you plug in 0, you just get minus 8 because it's 0 minus 8. If you plug in 2, you get 2 times 2 cubed minus 8. 2 cubed is 8 times 2 is 16, minus 8 is 8. So it's going to go from negative to positive 8. And so this is a simple case of a power rule. So this will give you 1/4 u to the power of 4. And the product of these two numbers is 1/24, u to the power of 4, going from negative to positive. Now, if you want to evaluate this, it's a tad easier using this, or you can go with the original ones. But I think this is easier because when I plug in, I'm going to write 1/24 brackets 8 to the power of 4 minus negative 8 to the power of 4. Because the exponent is an even number, of course, this is 8 to the power of 4. This is also the same as 8 to the power of 4. Minus 8 to the power of 4 or 8 to the power of 4 are the same. And the result is 0. You don't even have to know what's 8 to the power of 4 because it's the same as 8 to the power of 4. They cancel each other. You get 0 times 1/24 or simply 0. This is from exam review. You can find it under the module for this exam, of course. The rate of growth of a fish population was modeled by the equation g of t equals 30,000 e to the power of negative 0.6t over the parentheses 1 plus 5 e to the power of negative 0.6t squared, where t is measured in years since 2000 and g of t in kilograms per year. If the biomass was 40,000 kilograms in the year 2000, what is the predicted biomass for the year 2020? Round your answer to the nearest whole number. All right, first and foremost, the moment we hear rate of growth, that is the derivative function. So if capital G of t represents the biomass at any time t, then the growth rate, capital G prime of t or lowercase g of t, is this function. And if we want to go from the year 2000 to 2020, we can take this to be the initial time, and therefore the initial value is 40,000. Capital G of 0 is 40,000. So we have seen this question, this type of question word problem with integration, except we then need to do the substitution. The reason this question is here because we need the substitution. So based on what we discussed, known as accumulated change or the net change theorem, the amount of increase takes place with the integration of g of t dt from 0 to 2. Again, the year 2000 is the starting point, and then 2020. And so 0 to 20 and g of t is replaced with the function. Now, again, the reason it's here because it requires substitution method. So anytime you have a fractional format, number one, you make sure it's in a simplified format. And number two, the denominator without the choice of the exponent is u. So u is this expression 1 plus 5 e to the power of negative 0.60. So what is du? First, let's discuss the derivative of this function. The derivative of this function, remember, is itself 5 times negative 0.6 and then itself, because an exponential function. 5 times negative 0.6 makes it negative 3 e to the power of negative 0.60, because 1 is a constant, it gives you 0. So 5 times negative 0.6 is negative 3 e to the power minus 0.60. That's the derivative. And then du is the same thing times dt. So when we look at this expression, we see the bottom is u squared. And by the way, dt belongs to the numerator. So we want negative 3 and we don't have it. You have two choices. You can say, you know what, let me put the 30,000 outside the sign, the integral sign. And then I put negative 3 out and I divide by negative 3. Or one easy way, and again, this is a basic math, recognition that this number is the product of this number and something else. So 30,000 is the product of -3 and what? -10,000. Because this number is divisible by -3, we are in good shape. We can put the -10,000 outside. And now we are looking at du over u squared. And we're going to write that with the -10,000 in front, and we're not going to write the limits because those limits, 0 and 20, go with the original variable t, not the new variable u, and we're going to figure it out in a moment. So first, again, we have seen this integration before. Remember, it's going to use the power rule. First, you have to write this as u. Use a different color, everybody. You're going to write this as u to the power of -2 du. And the answer is 1 over -2 plus 1 u to the power of -2 plus 1. This whole thing, this is -1. 1 divided by -1 is -1. And this is u to the power of -1. So what you're looking at is -10,000 times -u to the power of -1. We're not going to have the limits yet. We're going to evaluate the limits in a moment. So first, please understand this is positive 10,000 because it's negative times negative divided by u. Now, what are the limits? Let's figure it out. If you plug in 0 here, please understand you get 1 plus 5 e to the power of 0, which makes it 1 times 5 is 5 plus 1 is 6. And if you plug in the upper limit 20, 1 plus 5 e to the power, what is minus 0.6 times t equals 20 is minus 12. That's why the upper limit is 1 plus 5 e to the power of minus 0.6 times 20 or minus 12. The lower limit showed it to be 6. Now, to evaluate this, let's take the 10,000 out. Let's write it 1 over u, and let's write it 6 to this number. Now, this number, class, if you put it into a calculator, it becomes almost 1. Becomes 1.0000031, which is almost 1. So we're going to write 10,000 times 1 over 1 minus 1 over 6. And 1 over 1 minus 1 over 6, that is 5 over 6, giving us 8333.3. And since we are rounding to the nearest whole number, next to this is 3, so this is not going to change. 8,333 kilograms. Originally, in the year 2000, we had this much. They will be added. So year 2000, 40,000 kilograms. And in year 2020, we added this much. So the sum of the two is 48,333 kilograms in the year 2020. I also want to remind you of the second method we looked at, and that was, instead of finding the definite integral, we're going to go with the indefinite integral, and then the initial value g of 0 equals 40,000 will give us the constant. So I'm going to see that we've gone through the process, so we're not going to repeat any of this. I come here and I see I have 10,000 over u. Okay, so I'm going to write 10,000 over u, which is 1 plus 5 e to the power minus 0.60, and a constant. So I'm using this one. We've come this far. I'm going to put it here, and I'm going to replace the u with this, and g of 0, we know it to be 40,000. So again, this one we've done, plus a constant, replace the u. Remember, g of 0 is 40,000. The fact that because 1 point is given, we can figure out the c. So let's plug in 0. When we plug in 0, we get 10,000 over 1 plus 5, plus a constant is 40,000. You do the math, you find this, and C ends up being 38,333. So G of t becomes this function plus this number. Now, the advantage of this is that if we want to predict the biomass in the year 2020, we put 20 here. It gives us the same answer. If we want to predict the biomass in the year 2025, we don't have to go through the same process again. You just replace the t with 25 here. So that's the advantage of that when we find the general, solution and then use the initial value to find the particular solution. Now in this page, I want to evaluate a bunch of integral, and I want them side by side because when I compare and contrast. The first one is the integral of 2x dx over 1 plus x squared. The second one is the same thing, the integral of 2x dx in the numerator, but the denominator is same thing being raised to some power. It doesn't matter, it's the power of 2 or 20 or 10. The process is the same. Now, first and foremost, you want to simplify, meaning put it in lowest term. There is nothing you can do. The choice of u is 1 plus x squared. And it's the same thing here without the exponent. 1 plus x squared is u. Its derivative is 2x. Therefore, du is 2x dx. So this is very straightforward. Is the integral of du over u, which is a natural log. And you replace the u with 1 plus x squared. On purpose, I've lost the absolute value sign just because I want to make a point, and that is, remember, 1 plus x squared is positive. In fact, it's always greater than or equal to 1. So you can lose the absolute value. If you have doubts, don't. For part B, we're going to use exactly the same that we did here, the same u and the same du. So we have du over u squared. And now, I hope you remember that we did this. In fact, we did it in the previous page, previous example. And so we bring the u up, make it u to the power of -2. Du, meaning we are going to use the power rule, 1 over -2 plus 1, u to the power of -2 plus 1, and a constant. -2 plus 1 is -1, 1 over that is -1. So this is negative u to the power of -1, or negative 1 over u. And so the final answer is -1 over u, which is 1 plus x squared, and a constant. In this case, the answer is -1 over 1 plus x squared plus c. In this case, we ended up with a natural log. So compare and contrast. The u and du are identical. The results are slightly different. In this case, if you have enough practice, you may recognize what you have to do as far as the answer is concerned. But I highly recommend you go with the substitution to be able to show your work and justification. You want to put this in lowest term. By the way, notice it's 1 over x plus 3 times dx in essence. So it is in its lowest term. U would be the denominator, which is x plus 3. The derivative is 1. Therefore, it makes du equal dx, or 1 times dx. So you're looking at the integral of du over u. Following the format, it's a natural log of absolute value of u plus a constant. Replace the u, becomes natural log of absolute value of x plus 3 plus c. Two things. Number one, if you differentiate the results, you get the original integrand without the dx, number one. Number two, in this case, I could lose the absolute value because 1 plus x squared is positive. In fact, it's greater than or equal to 1. But x plus 3 is not. It can be positive, it can be negative. Therefore, you must keep the absolute values.